Hello, this is Timothy Wood with Citadel Civil Engineering. This is CIVL202 Statics, and in this video, we're going to be talking about our procedure for analyzing problems. So one of the things that's important to recognize, hopefully you've already watched the 3 models videos where we talk about reality, our mental model, and our engineering and math model, as well as our process and format for how we're going to solve our problems and work our homework. Hopefully you've seen all of that. When we get to that procedure step, we're going to establish a few basic rules that we will always use in our procedure. So you'll use them in homework problems 1 and 2. We're going to write your procedure down on the board basically right now. In future homework problems beyond homework problem 1 and 2, we're going to assume these steps and we're going to move into other steps as we go forward. So hopefully that makes sense to you. So let's lay out our procedure. Again, this is section 1.5 and 1.6 of your textbook that walks us through the process. So, procedure. Our first step in any given procedure is exactly where we ended our conversation about terminology and units last time, which is to say that we will always use units. Always. Every single time. Always going to write our units down. So if you write a number down on a piece of paper in your statics class, or really anytime ever because you're training to be an engineer, you're going to make sure that that number, if it represents a physical quantity, has the units attached to it. You want to always make sure that that's the case. And even when we talk about things, you're going to want to make sure you provide that unit with it. So think about it. This is how life works, right? If we go back to our analysis of a burger and we talk about you don't go to McDonald's and order a quarter with cheese. What's a quarter with cheese? No one knows, right? Do you want a quarter cow? Do you want a quarter ounce? What do you want? Oh, you want a quarter pounder with cheese. You want a 1 Newton with cheese. That's what you want. So we're always going to have our units on there. So every time you write a number, write the units. If it's an equation, if it's on its own, if it's in your given or your find or your answer, every time write the unit down. All right, so we start by writing our units down. The next thing we're going to do is we're going to take those units and we're going to convert our units to base units. Maybe you use the railroad track method. Maybe you just multiply it by the factors. But again, you're writing our units on our unit conversion as well. So whatever those factors of 1 we're multiplying by to convert our units, we're going to want to do that. So we're going to write our units, convert to our base units, and we'll see that the units that we were given will cancel out when we multiply by 1. We'll have to see this in an example that we'll do together in class, but in general, we're going to convert to our base units. The other thing that we're going to say is that we're going to stay in our native units. So unless the problem specifically asks you to convert between unit classes, between SI and US customary, you're going to keep it in the same system that it was given to you in. Okay, and this is super important. So if you look at this, can be the difference between hitting Mars and going into orbit around Mars. There was an example you can look up about a Mars rover that because of a unit conversion problem, they got the rover all the way to Mars. It was supposed to go into orbit, but instead it just smacked into Mars and burned up. And so that's not what we want. So we're going to stay in our native units to avoid excess unit conversion and the errors that can come with that. The next thing we're going to want to do is we're going to want to solve our problems symbolically first. Solve symbolically. I hope you like algebra because you'll be doing algebraic manipulations of simultaneous systems of equations so that you can get the variable you're looking for on one side of the equation and the equation in letters on the other side as we've solved the problem symbolically. So you'll start by solving symbolically and then we'll insert our numbers with their units at the end. Then use numbers with units at the very end. So the first step, solve symbolically. So we're always writing our units, we're going to convert to our base units, and then we're going to solve symbolically in the last step. Our final, after we've solved symbolically. Our final step is going to be to report our answer. And when we report our answer, so we're writing down in the answer part, we're going to write it in the answer, whatever it said, we said we were looking for in the find segment, and we're going to follow some rules. The first thing in this class, we're going to generally use 3 significant figures. So just because your calculator gives you a bunch of numbers, we need to recognize that these things match some sort of physical reality, and typically we just don't know that sort of precision. So as a geotechnical engineer, when I look at a field and I've drilled some little holes and I've pulled some soil out and I've said, well, I kind of know the capacity. Well, I kind of know the capacity or the type of soil. I'm never going to claim to know the capacity of the foundation in reality to some sort of infinite precision. Typically, I'm going to use 2 or 3 sig figs. And so we have to think about the type of problem we're working with to understand the appropriate level of significant figures. But in this class, in general, we'll use 3 significant figures. We'll also want to use engineering notation. Your calculator probably has a button for this, but the idea is that if we have numbers between 0.1 and less than or around 1,000, that's where we want our main number to be, and we'll attach or append a 10 to the third power, so 10 to the third, 10 to the sixth, 10 to the negative third, 10 to the negative sixth, to get our main number in that decimal range between 0.1 and a little over 1,000. And that makes our engineering notation much easier to manage. So 0.1 to 1,000, you just put the number in there. Otherwise, we're going to have a 10 to the third or a 10 to the negative third going out in thirds to put it in engineering notation. If we're using SI, we can then convert that engineering notation to prefixes and put that prefix in front of our first unit. So remember, we're always writing our units, so our prefix turns a 10 to the third into a kilo, K. So we can have a kilometer, that's 1,000, 10 to the third meters, kilometer. We can also use others, so we have milla, centa, deci, killa, giga. All of these things are different prefixes. So if we're using SI, we can attach those prefixes. One example in US customary would be that we sometimes talk about kilo pounds, 10 to the third, 1,000 pounds. And so again, we can use the prefix in that case. But most of the time, we're going to just use prefixes in SI. And then finally, we're going to check for dimensional homogeneity. Ooh, that's a fancy word. Check dimensional homogeneity. Okay, so dimensional homogeneity means that all the dimensions are the same. So when we plugged in our numbers with our units, we're going to cancel out some of those units, and we should be left with the same units on both sides of the equation. That's what we mean when we say check dimensional homogeneity. And hopefully that matches. So if we were looking for a force, we'd expect the units to come out in pounds or in newtons. If we were looking for a mass, we'd expect the units to come out in kilograms or pounds second squared per foot. That's a slug. So that's the sort of thing that we're looking for there when we talk about dimensional homogeneity. This is the procedure for homework problems 1 and 2, and this becomes the assumed practice that we're always going to write our units. We're always going to convert to base units. We're going to solve symbolically first. This may be something you don't like doing. You like plugging in numbers as quick as possible and carrying them around, but you're going to get rounding errors and transcription errors doing that we can avoid by solving symbolically. And at the very end, we can plug in numbers with our units. We report our final answer with 3 sig figs in engineering notation, converted to prefixes if we're using SI, and we make sure that the units are reasonable for the value we solve for. I look forward to working an example problem with you in class to get some practice on this, and I'll see you then.